Hello and welcome back, everyone. Once more, I begin in the name of God, the most gracious, the most merciful. Just a few points to raise before I get into the program. At the time of recording this session, I was suffering and am suffering from a flu, and so my voice will sound different at various points through the duration of this delivery. And for the licensing agreements, these are my own works, with date of program being Friday, the 7th of February 2025. Appearing between the date in the bottom right corner is the LRQA certification, Rose Gold. At the center of the screen is a picture of me in 2012 with Gucci Rose overlaid. And without further ado, I'll run the graphical solutions from the three-dimensional momentum equations using the underlying source code I provided in Engineering Principles, Aerospace, and Elite Motorsport. And so to begin the program, I defined a testing function using a single particle element from R3 mapped onto the XYZ plane in computational space with the Z axis not seen here. One can see momentum follows a stable spiral where the programming solutions are undefined in the vertical axes. Furthermore, we can appreciate the use of ordinary differential equations in systems theory in the limits of advanced systems thinking. As t tends towards infinity, in the pressure function 1 over t, where t is time. Thus, pressure correction is applied to systems in R2 by elements in R3. And since pressure correction systems are indeed only a constant, any advanced theory from advanced systems thinking in R3 should instantaneously be able to remove pressure from the system in R2 entirely. And so, having rerun our debrief of the academic faculties within our cross-institutional fellowships and cohort, any and all resulting analysis from programs from Microsoft Power BI, for example, can only be deemed appropriate and applicable from observations of virtual environments, since for any sophisticated programming design from an element in R3, one is unable to use theories or theories of change from differential systems in R2 to track the behavioral motion and change from the limit cycles seen from an advanced systems thinking program in R2. And so, dropping the lower order approximations of higher order verticals, one is able to map the full three-dimensional momentum equations projected onto a two-dimensional space in the xy plane for all time t. And so for any other element in R3, using scripting languages widely used in R2 as industry standard, one is only ever able to approximate the precise location in time and space, but it can never be known with precision, since programming languages accepted as industry standard, or that which can be created using our basic understanding from elements in R3, programs within R infinity, including R3 and R2, will stand tested to incompleteness and higher order exploitations. And so virtual learning environments, for example, and the foundational knowledge we provide engineers and consultancy firms will be capped at the limiting functions posed on computational domains by collective elements in R3, in other words, Cartesian nodes. And so one has it then that a complete systems thinking theory requires no approval from committees due to the absence of audit risk and assurance, since such committees have only been verified by learnings from virtual environments. And outside of non-virtual environments, the finite element chairing the committee can only claim authority and ownership, supported by the membership, subcommittees, and supporting bodies. And so we have it then that a higher order element, independently acting in both R3 and R2, virtually maintains stability across the whole environment, since outputs cannot be captured by deterministic timeframes. I will now address your minister solutions for the horizontal momentum equations by considering the normal flux through the surface boundary of a fluid parcel as shown in the diagram on the right hand side. And so I'll provide a step-by-step walkthrough of the equations and its resolution, where u is horizontal velocity, b is the surface boundary of the fluid parcel, and n is the fluid flux through the parcel of fluid. It is a normal vector with components jx, jy, and jz, which are single component vectors of unit length scales. Upon combining these terms together, we get b to the un, where the dot represents a scalar dot product. By squaring equation 1 and dividing with equation 2, noting that a non-empty set of any length can be reversed, we get a single equation describing 1 and 2 for momentum u, which we can describe with the flux velocity at the surface boundary, where the Greek letter xi is min, and partial subscript s equals I to the s. And so for any u momentum to the power of r or r prime, we derive the following global standard law, particularly relevant in this case for members of parliament, upon dropping the bar on u and seeing that e to the r is just the Reynolds number reversed, thus completing the proof. And so, as evidentially required for programs containing completeness, I've collected together and summarized the main statements here, and removed most of the contents along the perimeter. And if required, you can copy the solutions from here, for which alternative colours can be provided. Once again, I'd like to thank you all for listening and wish you all a very fond farewell.